Page 366, we're looking at review for lesson 6.1 through 6.7. So on lesson 6.1, this was on translations. Translations is where we slide something. Could be to the left or to the right, up or down, or a combination of those. So if you look at number 1, they want us to draw the image after translation of 3 units to the left and 2 units up. So what we're doing, just look at a point. Let's take this bottom left corner for example, and we're moving 3 to the left and 2 up. And that would be our new point right there. Same thing with the other points. So 3 to the left and 2 up. This one's in between. And so is this other one. And you don't have to draw like those red lines that I'm drawing there. Those are just a way to kind of keep track of where everything's at. And then what should happen when we're sliding that, when we're translating that, it doesn't change the size or the shape of this figure. They didn't put letters on this, but just remember if they put letters, you know, if this was A, B, C, D, then our new letters would be A prime, B prime, C prime, D prime. Okay, again, they didn't do that here, but usually we're going to have letters on these, and then we'll just put primes on our new figure. Section 2, we're looking at reflections. So reflection is like a mirror image, or you might think of it as flipping something over. And usually we're doing this either over the x-axis or the y-axis. What's going to happen again is if you do the mirror image of something, or if you flip something over, it's still going to be the same size or shape. What we're going to do, like for number 1 here, they want us to reflect this across the x-axis. So here's our original figure. This graph they've given you in your book, there's not really enough room for you to actually draw this out, so this would be where we could do this on another piece of graph paper. And it does ask for the coordinates. So if we're reflecting across the x-axis, however far we are away from the x-axis, we're going to go that far on the other side of it. So when you're doing this, one idea is to highlight the axis that you're going across, just so you make sure you're flipping across or reflecting across the correct thing. So if you look at this, W is 2 units below the x-axis. So when we reflect it, it's going to go 2 units above the x-axis. Same thing for X. It's going to go 2 units above the x-axis. Z right now is 4 units below. It's going to go 4 units above. And same thing for Y. And again, make sure when you graph that you label your points. Remember to put primes on those. So X prime, W prime, Z prime, Y prime. Then the other question, the next part, is they're wanting us to reflect across the y-axis. So y-axis is going up and down here. So reflecting across that, X is 1 unit to the left, so it's going to go 1 unit to the right. Same thing for Y. W is 4 units to the left, it's going to go 4 units to the right, and same for Z. And so that should look like this. Since I did both of these on the same graph, I just went ahead and put a double prime on these points on the second one, just to distinguish that. And this one, technically it said what are the coordinates on number 1 and number 2. So you would have to say, like for number 1, you would have to say x prime -1 comma 2, w prime -4 comma 2, and so on. All right, but on your tests we might just do it where you actually just graph it out, and that's just good enough. Section 3 was on rotations. So rotations, we're turning something. So this is where probably the simplest way is if you just use tracing paper. Make sure you draw a line where the x-axis and the y-axis are, and then draw your square. Make sure you label what your letters are on this, and then we're doing a 180-degree rotation. Remember, if they don't tell us otherwise, we're assuming that they're going to have us translating this, or rotating this counterclockwise. So counterclockwise, this direction. Once the lines match up again, that's 90-degree rotation. And when they match up again, that's another 90. So that would be 180 degrees. So this should be what it looks like for number 1 with the 180-degree rotation, other than our letters are written upside down right now and there's no primes next to them. But those would be the spots where those letters would go. So on 1, they're just asking you to write the coordinates for that. So you could say S prime is at 4, 2, T prime is at 2, 2, U prime is at 2, 4, and V prime is at 4, 4. And then number 2, they're asking for the coordinates after a 270-degree rotation. Well, we've already done 180, so if we just do one more turn, that'll be a 270-degree rotation. So 270 degrees should take us here. I am off just a little bit. My drawing's not quite as good as it could be, I guess. But those coordinates for that one, it should be for number 2, and I'll just say double prime here, I guess. S should be at -2, 4. So I'll just say S double prime just to distinguish that. T should be at -2, 2. U should be at -4, 2. And V should be at -4, 4. Okay, so that should be that one, and then like I said, this should be about the locations for the points for number 1. Section 4, we're looking at transformations where maybe we have to do more than one thing. So on this one, they're wanting us to translate this rectangle 5 units down and then reflect it across the y-axis. So to do this, probably wouldn't be a bad idea if you want to just trace this out, or otherwise if you want to go ahead and do your translation first and then just write those points on your graph paper and then reflect it. You can probably actually do it without the tracing paper here. So 5 units down, this is going to look a little different for me because I've got this like already pre-drawn out, but we move down 1, 2, 3, 4, 5, and you guys can maybe just count the points. That's too many. Okay, so just each point, go down 5, mark it, go down 5 and mark it, and so on. And then reflect that across the y-axis. So for example, B and C are both 1 unit to the left of the y-axis. And again, make sure you've got the right axis that you're reflecting over. Here's our y-axis. So B and C are both 1 to the left. They'll both go 1 to the right of that. And then A and D are both 5 to the left. They'll go 5 to the right. So this should be our final answer here. Sometimes what the book did, you might remember, is if they had 2 changes, they might put a double prime on it. If this is the only thing we're writing, if that's just your final answer, if you just want to put primes, that's good enough. But do make sure you label the letters next to your points. Section 5 talks about congruent figures. So congruent figures are exactly the same size and shape as each other. On their example off to the side, kind of a little bit of a tricky there because these are different. They're not triangles. Remember, we talked about triangles. We could box those in. What you could do with these is you could just trace over one of them. If you trace over one of these on this example, and then try and turn it, flip it, whatever, it should match up exactly with that other one. Okay. On our question over here, they're asking whether these are congruent. And if you look at the measurements on the bottom side, it looks like, I mean, the top side's shorter on both of them here, so they're both turned the same direction. The bottom is 3 units for figure B, and for figure A it's 4 units. So they're not the exact same size and shape, so they are not congruent. Section 6 is on dilations. So dilations, we're either making the figure bigger or smaller proportionally. So if you look on number 1, they went a dilation with a scale factor of 3. So what I did here is I wrote the coordinates next to the points. I wrote the coordinates next to these points. Write them somewhere, okay? The coordinates, and then use your scale factor. So for this first problem with the scale factor of 3, that means we're going to multiply all of our coordinates by 3, the x and the y. So we were at negative 4, 1. Multiply both those by 3, it's going to be negative 12, negative 3. Negative 12, negative 3. I'm sorry, negative 12, 3. B was at 0, 1. If we multiply both of those by 3, that would be at 0, 3. C is at 1, negative 1, so it's going to go to 3, negative 3. And D is at negative 3, negative 1. It's going to go to negative 9, negative 3. And then what should happen when you connect your points, I'm off here on one of these. So B is up 1 too many units over here. I've got that in the wrong spot. Okay, so what should happen is it should look like the same figure, only 3 times, each side should be 3 times bigger than what it was before. And then we'll go through the same process when we look at number 2. And just take that number 1 answer off of there so we can see better what's going on. On number 2, they want us to use a scale factor of 1/2. So we're just going to take half of each of these coordinates. So A, instead of at -4, 1, we're going to go to -2, 1/2. Okay, again, you can either say times 1/2, or just if you divide by 2, that'd be the same thing to take half of those. B is at 0, 1, so half of both of those would be 0, 1/2. C is going to go to 1/2, -1/2. And D is going to go to -1.5, -1/2. So this is scaled down where all the side lengths are half the size of what they were before. Lesson 7 is on similar figures. So for similar figures, we've talked about the sides are proportional to each other. So this one, they're asking if ABC is similar to A prime, B prime, C prime. If you notice the letter positions, AB and A prime, B prime are in the same spots as each other. So if we look at those sides, AB length is 4, A prime, B prime length is 8. So if we do the new over the original, that's the same as 2 or 2 over 1. If we look at our other straight side, we've got AC is 3, and it goes to 6. So if you do 6 divided by 3 is 2. And we don't have a straight side for that other side, but if you form a rectangle, the rectangles would be the same. If the two sides are proportional here, it should end up that the other side's proportional as well. The other thing you could do, besides looking at the side lengths, you could look at the coordinates. Like B is at -4, 5, B prime is at 8, 10. And to get from the one to the other there, you would multiply by 2. Part of this is there's a reflection. So notice if you did -4 times 2, that would be actually -8. But if we reflect this first and then double those values, then those would work. But again, if you want to just look at the side lengths and see if those are proportional, that should be good enough. And then number 2 asks what sequence of transformation shows that those are similar. So one thing I might suggest first is to do a reflection here. So if we just take this triangle, we're going to reflect that across the x-axis. Should look like this. And then obviously it's bigger. The new triangle is bigger than this one. So if you look at the coordinates right now, this bottom corner is at 1, 1, and it's got to go to 2, 2. Well, 1, 1 to 2, 2 looks like we're multiplying by 2. We can double check that. This corner here is at 4, 1, and this one is at 8, 2, and we can double check that also with the top corners, 4, 5, and 8, 10. We already looked at 8, 10. Okay, so all those are double. So it is just those two things, like we said. So reflection across the y-axis and dilation with a scale factor of 2. Again, dilation is with the center of 0, 0, like we've been always doing. So this gives you an idea of what we're looking at in lessons 6.1 through 6.7. As always, good idea to go back and review some of the problems in the lessons, and also to go on to the PearsonRealize.com website to get some more practice.